Okay, so I'm going to do this as a little supplement to what the GPB videos did. Okay, first a little bit about the dot structures. I'm not sure whether they mentioned this or not. They said that the way that you draw the dot structures is you just put the number of dots around the atom that correspond to the number of valence electrons. And that is true, but there's correct and incorrect way to do that. The way that you want to do it is to make sure that at least every side of the atom has at least one dot before you ever double up. Okay. As an example of that, let me show you these two dot structures for oxygen. All right. If you were to say, okay, oxygen we know has got six valence electrons, one thing that you might be tempted to do is just say 1, 2, 3, 4, 5, 6. All right. And when you do this, you would notice that you have 3 of the sides that have lone pairs, or 3 of the sides have pairs, and then you've got this 4th side that is empty. All right. You don't want to do that. All right. The way that you want to do this is you want to draw it so that at least one side has, so that every side has at least one dot on it before you ever double up. Okay, so when I do this, each of the 4 sides has at least one dot. We need 6 electrons, so we need 2 more. Okay, and after that point, it doesn't matter where you put it. Okay, so I've shown 2 acceptable dot structures right here, but I could have equally have done it like this, where this way these 2 sides have pairs and there are 2 sides that have just single electrons. So any of these here would be acceptable. Another example would be something like fluorine. Right? With fluorine, there's a total of 7 valence electrons, and so the only difference would be which side is that single dot on. All right? These are just 2 of the acceptable ones. But for example, another acceptable way to draw it would be something like that. All right. So the reason I'm pointing this out is a little bit of vocabulary. The way I describe this is to say that whenever you have a dot structure, you have what are called sticky sides and non-sticky sides. And what I mean by a sticky side is any side of one of these dot structures that has a single dot. All right. And what's going to be important about that is a side of the atom that is capable of making a bond. All right? A non-sticky side is going to be a side of a dot structure that has either 2 or 0 dots. All right? And the important thing there is that that side is not going to be capable of making a bond. All right? So when you take a look at oxygen right here, no matter how we've drawn it here, you can still come up with the same number of sticky sides and non-sticky sides. So oxygen here would have 2 sticky, because no matter which way you draw it, it's got 2 sides that have single dots on them and 2 non-sticky. All right? And that's because no matter which way you draw it, there's going to be 2 sides that have a pair of electrons. Okay? Take a look at fluorine. All right? No matter which way you draw it, it's going to have 1 sticky side and 3 non-sticky. Okay? One more example would be if you had hydrogen. All right? Hydrogen's got 1 valence electron, so you could draw it that way. You could draw it with the dot on top. It really doesn't matter. But as far as like how many sticky sides, it's going to have 1 sticky, and then it's going to have 3 non-sticky sides. The only difference between hydrogen and fluorine is that there are the other 3 sides don't have any pairs on them, whereas with fluorine, even though the other sides are non-sticky, they all are non-sticky because there's a pair of electrons. All right, and what you'll see is that that will eventually lead to unshared pairs on a fluorine, whereas hydrogen will never have an unshared pair.